Hello guys, welcome to Channel Roan Basic. So let us solve your rational inequalities. Example, you have 3 over x minus 2 is less than 1 over x. Okay, so let us start. So first step is to simplify your rational inequality. This one, where assuming your numerator is denoted by r of x and your denominator is q of x, of course, you will follow the symbol and make the other side of your inequality 0 and simplify it into one rational expression. Okay, continuing. So let's put 0 on the other side. You have 3 over x minus 2. Okay? Then, we have minus 1 over x. Okay, so I guess you're following. So, by this one, subtraction property of inequality. So, you have subtracted 1 over x on the other side. So, you must subtract 1 over x on the other side to make it equal to 0. That's why we come up on this form. We have 3 over x minus 2 is 3x over x minus 2 minus 1 over x is less than 0. Okay? So I hope that we are clear in this one. Then simplifying this one, just follow your sign or symbol. 0 on the other side. Simplify it. We'll put it on one denominator. So the denominators are x and x minus 2. Okay? Then we have 3 on your denominator. So over x minus 2 and x minus 2. Okay? So the remaining, your LCD on this part is x. That will be multiplied to 3. So again, where did we get this x? So from your LCD of x, quantity x minus 2. If you divide it, x divided by x, so it will be cancelled. So the remaining is 3 over x minus 2 will come back on the top of your solution. Okay? So we didn't violate any mathematical rule. Okay. Continuing, minus. So the denominator is x. So we will not multiply x because it is a common denominator, just like this x minus 2. So we have 1 times the quantity of x minus 2. Or I guess that 1 times the quantity of x minus 2 is less than 0. Okay? So I guess we are clear with this. Or just multiply it, 3 multiplied by x and 1 multiplied by x minus 2. So we have come to this part. Then copy both denominator and multiply it as your LCD. Then, simplifying, we have 3x, then negative 1 times x, negative 1 times negative 2 is positive 2. So we have 3x minus x plus 2, then copy your denominator. Do not multiply it by distribution property. Just let it as in factor form. Okay? Then simplifying, we have 3x minus x is 2x plus 2 over x times the quantity of x minus 2 is less than 0. Okay? So if you can see, we can still simplify your numerator because 2x plus 2 has a common factor. So simplifying, on the top, We have here the common between 2x and 2 is 2. So we have x plus 1 over x, and x minus 2 is less than 0. Okay, if you will try to distribute 2 times x, 2x. 2 times 1 is 2. So we just put 2x plus 2 in factored form as 2 times the quantity of x plus 1. Just like this one. So I guess we are clear on this. So we will follow this inequality, not this one. Okay? So step number 2 is, again, your critical points. Critical points or critical values. Okay, so identify your the factors of your numerator. So we have 2 equals 0. So it will be an error. So we will not use this one. Another factor is x plus 1. Equate it to 0, then solve for x. So we have x equal to negative 1. So we will use this one. Then you have your x as a factor for your denominator equal to 0. So we will solve this one or use this one. Then another factor is x minus 2. Then equal to 0. So you have x equal to positive 2. So we have 3 values that we have to remember. Okay? So let us check whether these values are included or not. But to be more specific, this symbol is, look at the symbol. Symbol is less than. On the other example, we have the symbol or equal to, but in this example, we don't have equal to, just less than. So we can easily say that the 3 critical points cannot be included on your solution set, but they can be the barrier of your intervals. So let us solve it for you to understand it more. Okay? So we are on step number 3. So step number 3 is table of signs. So again, table of signs is made up or consists of, first, your interval. So making your table will depend on the number of intervals you have. So the number of intervals you will have will depend on the number of critical values or critical points. So assuming, let us visualize the critical values and the interval using a number line. So we have 0 on the center, 1, 2, and 3. Negative 1, negative 2, and negative 3. Okay, so we can find negative 1 in here. We have 0 in here. Then we have positive 2 in here. So if you can see, this one, your critical points are the barrier of your intervals. So if you can see, how many intervals do we have? So we have 1, 2, 3, and 4. So we will make 4. One, 2, 3, and 4. Okay? First, let us identify. Again, the values on the right are the values that are greater. So assuming this is your x as a part of your solution set, which is greater, x or negative 1? Between x and negative 1, which is greater? So of course, the value on the right, which is negative 1. So your equalities or inequality symbol will open on negative 1 because negative 1 is greater. Again, this side or on this part of interval, you have 2 points to remember. You have negative 1 and 0. And x is on the center. Okay. -1. Then you have 0. X is on the center. This one. So you have 0 and -1. So 0 is on the right side of x. So greater or opens on 0. While -1 is on the left side of x. So the value on the right side is x between -1 and x. So the symbol will open on x and will point on -1. Okay? Okay, next, let's proceed to this interval. So you have your 0 and 2. 0 and 2. So 0 to x is on the middle. So the value that is greater than x is 2. So opens on 2. And between 0 and x, the greater value is x because x is on the right side. So we have that interval. Then the last interval is from number 2 to its right. So x and 2. So which is greater? 2 or x? So x is on the right side of the number 2. So it will open on x. Okay, so we are done with your intervals. Let us proceed to your test points. So identifying your test points, you can also use this. What are the values that are less than -1? Of course, -2. What are the values between -1 and 0? Of course, the values in here. We have -1/2. -1/2. Okay? Then the values between 0 and 2 is +1. Then the values on the right side of +2, which is +3. Then we will have to copy your numerator, which is 2 times the quantity of x plus 1. Then another column for your denominator, which is x times the quantity of x minus 2. Then another column for both the numerator and the denominator. So we have 2 times the quantity of x plus 1 over x times the quantity of x minus 2. Okay? So that will make our table of signs. Now let us verify these test points. So it's known as the test points to test whether this interval are part of your solution set or not. Is this interval part of the solution? This interval, or this interval? Okay? -2. So -2 plus 1 is -1 times 2. So you will have negative answer in that. So if you have time, just evaluate again. -2 plus 1 is -1 times 2 is -2. Okay? Then -1/2. -1/2 plus 1. So -1/2 plus 1 times 2. So just do the substitution. So -1/2 plus 1, the greater value is 1 than 1/2. So you have +1/2 times 2. Of course, you will have the positive value. Then 1, x is equal to 1. 1 plus 1 is 2 times 2. So you have +4. Then you have 3 plus 1. Again, your x is 3 plus 1. So 4 times 2 is 8. You will have the value of a positive number. Okay, again, the table of sign is not concerned with the exact value but on its sign. Then we have -2. So -2, substitute -2 minus 2. So -2 minus 2 is -4. -4 times negative 2. Negative times negative will give you positive. Okay? Negative 1 half. Negative 1 half times the quantity of negative 1 half minus 2. So negative and negative will give you negative. Then negative 1 half. This one. Okay, you cannot get it. Negative 1 half minus negative 2 is negative 2 and 1 half. So negative times negative is positive. Okay, another one we have positive 1. X is positive 1. So 1 times 1 minus 2. 1 minus 2 is negative 1 times 1. Positive times negative is negative. Then we have 3. So 3 times the quantity of x, which is equal to 3 minus 2. So 3 minus 2 is 1 times 3. You will have a positive number, 3 times 1, which is positive 3. Okay? So I guess we are clear in this part. So again, your numerator, denominator. Then, numerator divided by denominator. So, this column, you have your numerator, denominator. So, on this part, we have your numerator divided by denominator. So, numerator divided by denominator. Negative divided by positive is negative. Positive divided by positive is positive. Positive divided by negative is negative. Then, positive divided by positive is positive. Okay. So, again, let's go back to this one. We will not be using this one. What is the symbol? So the symbol is less than 0. What are the numbers that are less than 0? Of course, all the numbers that are negative. Okay? All the numbers that are negative. So we will be using the interval above. So the interval above is x is less than negative 1. On this side, we have 0 is less than x, less than 2, or x is greater than 0, but less than 2. Now, let us present your solution sets. So your solution set may be presented again by a graph. So a graph we can use in here to present your solution set is a line graph. So 0 on center, we have positive 1, 2, 3, 4. Okay? Then we have negative 1, negative 2, negative 3, and negative 4. So we will be using this one. So again, let us put this critical point. So the critical points is open circle on negative 1, then open circle on 0, then open circle on positive 2. Okay. So on what interval is our solution set? Of course, x is less than 1 on this part. So we will shade this part. Okay? Another one is again, you will shade this part of your interval. Another one is the interval between 0 and 2. 0 and 2. So this one. 0 and 2. Or we have this one. Shade the interval between 0 and 2. Okay, so on your line graph, this shaded part represents your solution set. Okay? Second is the interval notation. Okay, it will be easy for us to write an interval notation if we can visualize it using your graph, such as one. So the intervals are from negative 1, this one, negative 1, until negative infinity. Okay. So this interval implies from negative 1, where negative 1 is not included, until negative infinity. Because it is not included, we will use parentheses. And we will use parentheses for your negative infinity, because we cannot determine where this negative infinity will end. Then on the other interval, we have 0 and 2. So we will use again parentheses, because 0 and 2 is not part or are not part of your solution set. And put U between them. This U denotes union. So union of two solution sets. Okay? The first solution is from negative 1 until negative infinity, union to 0 until 2. Okay? Last is the set builder notation. Okay, for your set builder notation, again, braces, x is an element of real number such that copy your interval. So you have x is less than 1, or because you have two intervals, just copy, then or again x is greater than 0, x is greater than 0 but less than 2. Okay, so I guess that we are clear on this lesson, the rational inequalities and how to find its solution. So again, on your equation, we are finding solutions, while on your rational inequalities, we have solution sets. So thank you. I guess you have learned something from this video. Stay safe.